Now for our next video, we're going to talk a little bit about electric force. And before we get into too much about the electric force, is because the Coulomb is such a large charge, it was on 6.25 times 10 to the 25th electrons or protons, we're going to be using a lot of the SI prefixes. So make sure you are familiar with those: mega, giga, kilo, centi, milli, micro, nano, pico. Most likely the smaller ones, but we might end up with some of the big ones for different problems. So make sure you're familiar with those. We're going to be using those quite a lot. But Coulomb's experiment was basically, he was taking known amounts of charge or controlled amounts of charge and using those to kind of figure out the nature of the electric force. So in about 1785, Coulomb figured out three basic facts by doing these experiments. The first one is that the force goes like 1 over r squared, and it's in the same direction from the one charge to the other. You draw a line between the center of one charge to the center of the other, and that force is always along that line, either an attractive force or a repulsive force. And basically the amount of force depends on the product of those two charges, how much each charge is exerting a force. And then the idea that opposite charges attract, like charges repel. And so Coulomb combined these into three basic ideas, his law of electric force. And it's the idea that there's this constant times the product of the two charges divided by the distance between them squared. And that Coulomb's constant is 8.9875 times 10 to the ninth. We'll usually just use 9 times 10 to the ninth. And then we talked about it in class, but see if you can figure out what the units of that should be just by looking at the equation. So I'm going to be doing a few practice problems as YouTube videos, but I wanted to give you guys a chance to attempt those before I post those, probably in the next couple of days, those of you who are watching it as I'm doing it. But the first one is the idea that you have by two identical 4 microcoulomb charges that are 3 millimeters apart. Part of this is figuring out what the force is. Part of it is going through each place there. So then you'll have the force, because we're going to use that Coulomb's constant, and now micro is 10 to the minus 6, so you have 4 times 10 to the minus 6 coulombs, but both of them are that same charge, so you square it, divided by the 3 millimeters, which is 0.003 meters squared, which ends up being about 16,000 newtons. And the question for you is that force attractive or repulsive? So then, what you want to look at is, for these particles, what is that charge? And so if we have electrons, protons, and neutrons, a lot of times we use the designation lowercase e to be the elementary charge. That's 1.6 times 10 to the minus 19th coulombs. That's the idea that each electron or each proton has a specific amount of charge, and everything is going to be multiples of that amount of charge. So this is another question that's going to be on the quiz. If you have two charges, A and B, they're placed near each other. A has a charge of 6 coulombs, B has a charge of 2 coulombs. How do those forces compare? Those are the three options. Be ready for that. Here's another one I'm going to look at a little bit on a separate video, is the hydrogen atom. It's 1 proton, 1 electron, separated by an average distance of 5.3 times 10 to the minus 11th meters. How do the electric forces compare to the gravitational attraction? So we want to compare those two different forces because we know what the mass and we know what the charge of each of those are. And then one that I will definitely be showing you is the idea of, you have 3 charges: a 5 microcoulomb charge at the origin, a negative 5 microcoulomb charge at the position x equals 2, y equals 0, and a negative 7 microcoulomb charge placed at the position y equals 2 meters, x equals 0. So what force is exerted on that charge, and what direction does it point? So if you're able to do that, you should be pretty well set with electric forces.